Hi, this is the lead developer of Formulize, a program that detects hidden mathematical patterns in raw experimental data. In particular, it identifies the equations that describe the mechanisms that produce the data, helping you make more accurate predictions and generate new breakthroughs in research. So Formulize is more powerful than other modeling approaches you might have heard of. It identifies crucial nonlinear relationships, it automatically determines what variables to use, it minimizes the complexity and the number of free parameters in the model, and ultimately, it gives you a fundamental new insight into the key features of your data. Here, I'd like to introduce you to the Formulize application and show you how to model your first data set. So let's jump right in. When you first start Formulize, this is what you'll see. This is the data entry view, where you can enter the values that you wish to model. So Formulize looks and acts just like an ordinary spreadsheet, but it uses a special format. So each column in Formulize corresponds to a single unique variable in your data set. And each row corresponds to a single state of the system or a single set of measurements that you made on the system of interest. So what you see here is an example data set that loads automatically. What I'm going to do is select all here and clear this out so we can enter in a real example. Now in another spreadsheet I have Excel running here, and I've stored some motion tracking data of a pendulum. So what I'm going to do here is select these values that I have in Excel, and I right click, I can hit copy. I go back into Formulize. If I click on the first data row here, I can hit paste. Now the values I had stored in Excel for this swinging pendulum over time are entered into Formulize. So the first column here was the time variable, so I'm going to give that a variable named t. And the next one here was an angle. I'm going to give that a variable name of x. And just so we don't forget, here I'm going to write a comment that says this was time in seconds, and this was angle in radians. So you can see there are two special rows in Formulize. There's a description row where I can enter in comments about each variable in each column, and then a variable name row where I can enter in the symbolic variable name for each column. So in Formulize there are several views, and typically what you do is work from left to right. So we start off here in the first view, this enter data view, and what we're going to do now is go to the next one, which is the prepare data view. So now we can see what our data looks like plotted. So if I click on T here, we can see that the time values are increasing linearly with the row number. If I click on X here, now I can see the angle of our pendulum as it swings back and forth. So this data is more interesting. We can see that the pendulum starts swinging to the left, then it swings to the right, then back to the left, and basically it oscillates back and forth here over time. But we can also see that the amplitude of this oscillation is decaying over time. And this might be to drag from air, or it could be some other dampening effect. And what we want to do is use Formulize to find the equation that explains why the pendulum behaves like this. What's the equation that captures the physics behind why the pendulum swings back and forth, and why is the amplitude decaying like this? So this is the type of questions that Formulize can be used to answer. So working left to right here, I'm going to go to the next view. This is the view where we tell Formulize exactly what we want to model. And the most important input here is the target expression, and this is a simple equation that uses the variables we entered in our spreadsheet, x and t, or whatever else we entered in. And what Formulize will do is it will use the special function f to find a function f using t in order to model x. So what this expression says is try to model the angle x of the pendulum over time as a function of time. But we can click on this, we can change the equation. We could say model x squared as a function of time. Or we could go back in and say no. Model the angle x as a function of time and x itself. Or we could say model x as a function of time and sine of x. But for this demonstration I'm just going to use the simple suggested expression here to try to model x as a function of time. So what's the angle as a function of time? And below that we can restrict and constrain the type of model that we find in order to model that angle x as a function of time. So here I'm using the default settings. We're going to allow constant coefficients, input variables, addition, subtract, multiply, sine and cosine. And since this is a physical system, I'm going to enable this extra building block here, the exponential. And that might help us capture the decay in the amplitude of the swinging pendulum. So working left to right, I'm going to click the next view here. This is the start view. And if I hit run, Now I'm telling Formulize to start searching for models. Search the space of nonlinear expressions in order to model that variable x. And on the left here we can see certain statistics about the search, like how long we've been searching for, how many CPU cores we're using. On the right here we can see the error of the best model over time. This gives us an indication of the progress of the search and how accurate the equations are. And on the bottom here we can see a detailed log of what solutions the search is finding over time. So if I click on the next view here, we can see the results. And it looks like Formulize has honed in on the key features of the data. So I'm going to go ahead and stop the search. And this stops using the CPU and pauses the output. So the first thing you'll notice here is this list of solutions. So the first thing you might notice is that Formulize doesn't find a single expression, a single model. It finds a very special small number of models. So you can imagine you can model almost any data set by using a really large, complex model. But what Formulize tries to do is find the simplest possible model that captures the key features. So what you're seeing here is the most accurate model that Formulize could find for increasing levels of complexity. Or in other words, it's finding different levels of approximation in order to model this data set. So at the very bottom here we have a very, very simple model, the simplest possible model, just modeling the mean, a single parameter. And if we go up in complexity, we might capture a little bit more of the features. Here, going up, we find we can capture, with a very simple model, just the simple oscillation, but none of the amplitude decay. If we increase this, we get a little more complicated. Suddenly we get to a model that's very, very simple, but captures all the key features that we wanted to capture in this data set. This is a very interesting expression here because it's so simple and it's so accurate. So we can look at how this model fits with the data on the right here. We can zoom in and see just how well it agrees with the data points. It seems to be capturing everything we wanted to capture originally. And we can look at this equation and interpret what it means. So on the right we can see that there's a cosine, a sine wave, and it's a function of t, and so it's oscillating back and forth in time with a frequency of 9.7. And there's a slight phase offset in this oscillation of 0.94. And interestingly, we can see that the amplitude of that cosine wave is being modulated by this exponential term. We can see that it's decaying exponentially with a coefficient of 0.336 because it's a negative decay as a function of time. And this is what makes the model kind of go down like this. So even though we never told Formulize we were trying to model a pendulum, it's basically derived the equation of a pendulum as it oscillates over time. And this is the type of things that you can do with Formulize. So we were lucky with this particular experiment because we were able to model the data very, very quickly. This is a very simple system. But more complex systems that use more variables, they have more noise, or they're just harder problems in general might take much, much longer. For example, a lot of typical users will run their searches for several hours or even overnight. Some problems even need to be used in the cloud or be run for weeks on end. It just depends on how difficult and how far you want to scale this problem. So I hope that helps you get started with Formulize. There'll be more tutorials coming soon that show you more complicated uses, but this is the basic get started essentials in order to use Formulize very, very quickly. So good luck and have fun.